Welcome back, my wonderful third grade math teachers. This is the weekly preview for content for the week of October 17th. All right, so this is a jam-packed week with a lot of readiness teaks. So let's go ahead and start looking at Monday and Tuesday. We have a problem-solving teak set in with a new teak, 3.5a. So we've been talking about 3.4a, solve with fluency 1 and 2 step problems involving addition and subtraction within 1,000 using strategies and the relationship between addition and subtraction. And we've talked about how that's been tested 13 times since 2016, 5 that were addition and subtraction, 3 where you had to add multiple numbers, and 3 where you subtracted only and the lower number was listed first. So we've talked about that in previous videos. But we're going to add with that 3.5a this week, which is represent 1 and 2 step problems involving addition and subtraction of whole numbers to 1,000 using pictorial models, which here is your strip diagrams mostly, number lines, and also equations. So we're talking about how to solve when we use those equations, and when we're using pictorial models, it's typically going to be a strip diagram. Every once in a while, it'll be a number line. This teak has been tested 9 times since 2016. So again, this is a teak that's tested quite a lot. Sometimes 2 times in a year, sometimes just once. Typically, if it's 2 times, 1 is an equation and 1 is a strip diagram. Okay. And then on Wednesday and Thursday, we will begin multiplication. Yay! And so we're going to start with multiplication using equal groups with manipulatives, and we're going to apply that to repeated addition. So when we do that, that's going to be using counters and other manipulatives, base 10 blocks, things like that. And so that teak is 3.4e, which is a supporting standard, and it's only been tested 3 times, that 3.4e. And so that's representing multiplication facts using a variety of approaches, such as repeated addition, equal-sized groups, which is the one we're working on Wednesday and Thursday, arrays and area models, which will be next week, and then equal jumps on a number line and skip counting, which will be beginning on this Friday. So that's only been tested 3 times, but it's critical in the conceptual knowledge of multiplication, and it will help with the readiness teak of 3.4k, which we'll also be looking at this week on Wednesday, Thursday, and Friday. So that is solve 1 and 2 step problems involving multiplication and division, but we're not going to look at division till we get there, within 100 using strategies based on objects, pictorial models, including arrays, area models, and equal groups, which you've heard in 3.4e, properties of operations or recall of facts. And when it says properties of operations, just note they don't have to know the names or the definitions of the properties of operations. They just need to be able to use them. For example, they need to understand that 2 times 3 is the same as 3 times 2. 2 groups of 3 is going to give you the same product as 3 groups of 2. So this has been tested twice with multiplication and then division, like that's a 2-step. It's been tested 4 times with a 2-step of multiplication and addition. Sometimes they'll have to add first and then multiply. This is a heavily tested teak. For right now, we're obviously not going to focus on the 2-step of multiply and then divide because we haven't learned that yet. But we can, even when we're teaching equal groups and using manipulatives, we can still teach that in the context of adding together and then multiplying. So having that 2-step, because that has been tested 4 times in that area. Okay, so let's start with 3.5a. I'm not going to go into the 3.4a IQ released items because we've done that for several weeks. I'm going to jump in with 3.5a, but it goes well with 3.4a. This is just, we're adding the pictorial strip diagrams, or like this question, the equations. So Tyrese has 572 baseball cards. Okay, so that's the total amount of baseball cards he has. He sold some baseball cards. We don't know how many. And then he had 98 baseball cards left. Which equation could not be used to find the number of baseball cards Tyrese sold? Since this is a not question, that means that there are 3 correct ways to find the number of baseball cards he has left, and 1 that's incorrect. This is the reason that when we have you teach students to find one way to solve, we typically ask you to have students at least try to find 2 equations that would show you how to solve. This makes my heart happy because I can remember back in high school where we had some teachers that would say, you have to use this way, but there was more than one way to solve the problem, right? And so this kind of shows that there is more than one way to solve a problem. And so that's what we want students to be thinking of. This is going to push your higher kids because they're not going to stop with just finding one way. When they find one way, push them to find another way. Push all your students to try to find another way, because this question was on the STAR test for every kid, okay? And so one way to help them with this is to use the other part of this TEK, and that is using a strip diagram. We know that this is just like a part whole mat, which is what they used in K1 and 2 in order to help them solve problems. And so students know that the whole or the total usually goes at the top, but it just goes all the way across. So it could be on the bottom, but either way, it goes all the way across. And typically we just put the total at the top. So we know he had 572 baseball cards. We don't know how many he sold, but at the end he had 98 left. We're looking for a missing part. And so we've taught students since 1st and 2nd grade that when we're looking for a missing part, we subtract. But there's more than one way to actually solve this problem. So let's look at these choices and see if these make sense with our picture. 572 is the total. If we take away blank, that would equal 98. Does that match our picture? It actually does. So that would be one way to find out how many cards he sold. But we're looking for the not, so that's not going to be our answer. What about 572 minus 98 gives us our blank? This is the way typically most of our students would do this problem. They would take the whole, take away the part they know, and that would give us the part we don't know. So that again is a great equation for how to solve this problem. Now let's look at this one. It doesn't have subtraction on it, but could it work? Let's think about this. If we have 98 plus this blank, would it give us 572 the total? Yeah, it would, wouldn't it? So we really have to start kind of thinking outside of the box. And so let's look at this last one. Would it make sense to add 98 to the total number of cards to find out how many he sold? Yeah, that one doesn't make sense. So that would actually be our answer, our not question, okay? I really think on this one, since the answers were all over the place in this state, that students were not picking the not, they were picking one that worked, and all 3 of these worked, and that's why our answers are all over the place. So we have to pay attention to the not in the question, and then building our own strip diagram to help us decide which equations could work. So this is a great think aloud. All right, and so another way this TEK is tested, 3.5a, is looking at which strip diagram would match how to solve this problem. So this is very similar to what we just did, isn't it? But this time, they've drawn the strip diagrams and we have to see which one works. So it says there are a total of 294 restaurants in a city. Remember, we just talked about how the total should go all the way across. It should be the whole. And if I look at these, only one of them has 294 in the total, in the whole. So right away I'm thinking these are probably not the right answers before I even read the rest of the question. So there's a total of 294 restaurants in a city. Of these restaurants, 196 are along highways and 49 are downtown. The rest of the restaurants are in shopping malls. Which model can be used to find the number of restaurants in the city that are in shopping malls? So since I think this one might be my right answer because the total of 294 is here, let's see if it works for the rest of the problem. Of these restaurants, 196 are along the highways, 49 are downtown, and the rest, the one we don't know, are in shopping malls. How many of the restaurants in the city are in shopping malls? So to me, this looks like our correct answer because this one, they're adding the total restaurants to the restaurants along highways, to the restaurants that are downtown to find the rest. Like, that doesn't make sense. This one, they just have these two in the wrong place. And this one, 49 cannot be the total, right? That doesn't even make any kind of sense. Most of the students that got it wrong, though, notice they picked this one. And I think that goes along with what most third graders want to do. They want to take all the numbers and add them, right? And that strip diagram goes with that theory. So we've really got to teach them, where does the total go? Where does the whole go? Okay, in 2021 and 2022, they started doing the equations a little differently to where they put the first step up here and the second step underneath it. And so that tells me they're kind of going in a different direction in the way that they are showing the equations. And so I need to know that in my teaching because we need to practice some that look like that, right? Okay, so a cafeteria sold a total of 513 drinks on Wednesday. So if I were drawing this in a strip diagram, I would put 513 at the top, right? The table shows the number of each type of drink that was sold. The number of bottles of milk is missing from the table. Which set of equations can be used to find the number of bottles of milk sold? Again, I would have a strip diagram. I would have my students, every time we do any kind of word problem, 3.4a or 3.5a, let's draw a strip diagram to help us decide what operations we're going to be using. This is obviously a two-step, right? So I would have my 513 drinks on Wednesday. That's my total number of drinks. And so I would have that at the top all the way across. Then my bottles of apple juice, you'll notice I have the 172 here. And then my bottles of water, my 263 I have here, but I have a missing part. And I know that typically a missing part is subtraction, but I have to do something first. Before I can subtract these two from this, I need to put these two together, don't I? Because I don't see over here where we start with 513, we take away 172, then we take away 263. I'm not seeing that, but it could be there, so let's look. Okay, if I put these two together, 172 and 263, I would get a total of 435. Okay, and once I have 435, how can I find out this missing part? I would need to subtract it from the 513. This right here has 172 plus 263 equals 435. That part's right. But then it would have me add the total number of drinks to the total of these. Is that going to show me my missing part of milk? Not quite. In this one, we're taking this 263 and subtracting the apple juice. Is that going to help me find the bottles of milk? This one I have 513 minus 172. Okay, I could start that way, but then from there I would have to take away the 263. And look at this. This has us adding the 263. That doesn't make sense. So our last one, when we add 172 plus 263, we add these two pieces, we get 435. And then from there, we take the 435 away from this, and that'll give us our missing part. And that's exactly what this answer choice shows. So making sure that sometimes we show the two steps like this instead of just in one single equation. Okay, so how do we teach this? Okay, because this is a lot, right? And so one of the ways that we teach this is we use Nancy's problem-solving mat. And so this looks like a lot, but actually what you're going to do is you're going to cut out these cards for every pair of students. And you're going to have them justify where each one goes on the placemat on the following slide or the following page about where they go. So the work is done for them for this word problem, but they have to put the cards where they go and justify and talk to each other. In this one, the reasonableness one had been done for them, and the students would just have to talk about which place do these cards go. But before we can do that, we've got to read the problem. Shirts R Us has 239 green shirts and 318 blue shirts. Clothes for Less has 126 fewer green and blue shirts than Shirts R Us. How many green and blue shirts does Clothes for Less have? Okay, and so it'll make more sense when I show you what it will end up looking like. Your students will have a blank placemat where they have to put each of these pieces. They have to put a drawing in one piece. They have to put an equation or two in the next piece. Then they have to put an estimation. Then they have two different ways to solve, and they have to put those in either one of the boxes, okay? So, like I said, the work's been done for them. They just have to decide on this placemat where each piece goes. Typically, the strip diagram is going to go in the draw picture, but what we want here is for students to have that discourse. We've been working on talk moves this year, right? That's been our math goal, and that's what we've trained our teachers on, is having that student talk. So right here is where you're going to have students turn and talk about why this picture matches this problem. Because we've got to start with 239 green shirts, 318 blue shirts to find out how many total green and blue shirts Shirts R Us has. Once we find that out, that it's 557, we have to take away 126 green and blue shirts from Clothes for Less because it says they have 126 fewer green and blue shirts. Fewer is very important, and it's going to be even more important when you're doing your input and output tables. So we talked about that a little bit in our last video, okay? So that one would be a subtraction to find the missing part of how many fewer blue and green shirts Clothes for Less has. Notice that when you look at this strip diagram, it actually has two steps. Look at our equation. What's our first step? Does this match that strip diagram? It sure does. So again, you're having students right here justify why this makes sense. Why are we adding these two? And then why are we subtracting 126? We want them saying to each other, we have to subtract that from the total number of blue and green shirts from Shirts R Us because they have 126 fewer. We want them using this academic vocabulary, okay? Then this one is the estimation. The reason we're working on estimation is because we want to relate it to the reasonableness of the answer that they get when they go through this process or when they're solving a problem. So how does this make sense right here? Well, this is the students justifying again. So Shirts R Us had about 200 green shirts and about 300 blue shirts, which gives me about 500 green and blue shirts. And then Clothes for Less had about 100 fewer green and blue shirts. So I'm going to take this total and take away about 100, and that gives me about 400 green and blue shirts for Clothes for Less. Okay, so that's my estimation to see if my answer is going to be reasonableness. Now, the first word problem that you do with this, you're going to be modeling a lot of this talk and asking the students to turn and talk and then sharing some of those ideas out because they're not going to naturally have these great conversations. So we're going to model with kind of an I do, and then we're going to do some we do's with their together as a class, and then we're going to do some you do's where they do this as partners. But it's all about the justification. It's all about the talking and making sense of these cards and what's happening. Later on, we'll go to where you give maybe 3 of the cards and the students have to come up with 2 of the cards. For example, maybe you show the strip diagram card and they have to put it in the right place, but maybe they have to come up with the equations. Okay, and maybe all the rest of these are done for them, but they have to kind of look at the strip diagram and read the problem in order to come up with the equations on how to solve, okay? So this is how we're teaching both parts of 3.5a right here together, strip diagram and equations. And then down here, we can use two different ways to solve. So I solved it the first way just using the standard algorithm. I added the first two together because that will show me how many green and blue shirts they have at Shirts R Us. And then I'm going to take away the 126 fewer green and blue shirts from Shirts R Us. And that gives me 431 blue and green shirts at Clothes for Less. Hey, wait a minute, 431, that's close to my estimate of 400. So that means my answer is reasonableness. It's reasonable. And so then I've got another way here that I solved it, because you can always solve it more than one way. And I just used place value blocks. We had 239, and then we had 318, and then we kind of put those together, right? And then we were able to subtract. When I put these together, I noticed that I had another group of 10, and I traded those 10 for a 10 here. But when I subtracted 100, 10, 27, that left me with 431 blocks left over. Okay, so that's a lot of work. You don't have to do all of the problems that are in these slides. Model one, do one together as a class, then do one in partners, and that's plenty, guys. 3 problems done with this many teaks in it, that's absolutely enough for a day, okay? And you actually have 2 days for this teak, okay? I'm going backwards, sorry about that. Okay, so now let's look at our next teak, 3.4e. 3.4e is represent multiplication facts by using a variety of approaches, such as repeated addition, which we'll be working on this week, equal sized groups, which we will be working on Wednesday and Thursday, arrays and area models, which will be next week, and then equal jumps on a number line, and skip counting, which will be this week near the end of the week. Okay? So, this problem was from 2022. Gia lists some different methods she thinks she can use to solve the multiplication problem shown. 7 times 11, I like to also say 7 groups of 11. I like to say it both ways so that students know what multiplication means, okay? And so this one, again, we have another not question, right? Which answer choice is not a correct method for Gia to use? And so if we look at A shows 10, 11 with place value blocks. Do we have 7 groups of 11? 1, 2, 3, 4, 5, 6, 7. We do. So this is not our answer because we're looking for one that does not show 7 groups of 11. Now look at this number line. This one to me looked a little tricky. And once I looked at it and analyzed this number line, I noticed something because I was like, how are they doing 11? Wait a minute. This one looks like it's in between 2 numbers. So then I started thinking, okay, I've got to really look at this and analyze this number line because it's not counting by ones, is it? Look at that. 2, 4, 6, 8, 10. And that's why when it goes to 11, it's in between the 10 and the 12. Then we do another group of 11, which would give us 22, 33. So again, it's in between. But so this is actually going by 11s, but the number line is counting by 2s. Do we have 7 jumps of 11? 1, 2, 3, 4, 5, 6, 7. Ooh, we've got to really analyze these number lines. And so that's starting on Friday's lesson. So keep that in mind. The next 2 both look like they are skip counting, don't they? One thing that we will notice is that if we teach the pattern of 11s, this is going to be pretty easy, right? We know that when you multiply by 11, we see the pattern right here in our digits, in our 10s and 1s digits. They're the same, right? And so we're going to help students when we talk about our 11s by teaching them these things. Just list them out and say, what do you notice when we multiply times 11? So list them out vertically. 1 times 11 is 11. 2 times 11 is 22. 3 times 11 is 33. And so just have those written out vertically and ask students, like, what do you notice as the pattern? But if we skip count by 11s, do we have 7 times here? 1, 2, 3, 4, 5, 6, 7. And it would make sure that 7 times 11 would be 77, right? Let's look at this one. If we skip count by 7s, it looks like they're starting with 7s, right? What would be next? Should be 14, shouldn't it? And then 7 times 11 is not 73. The other clue that shows me this is if I were counting by 7s, I would need 11 numbers here. I would need to skip count 11 times. 1, 2, 3, 4, 5, 6, 7. So if they had skip counted right, this would be 7 times 7, which they didn't even skip count right. So the not answer here is answer choice D. Okay, another way this has been tested is where they kind of show like which 2 number sentences can the model represent. Again, I love this because it's showing there's more than one way to solve a problem, but we have to analyze each one of these. So when we look at this and we see 3 groups of 3, well, I see 1 group of 3, 2 groups of 3. So already I know this is not the answer choice we're looking for. Is it 3 plus 3? Yes, but it's not 3 groups of 3. So let's look at this one, 3 groups of 2. Well, if I go up and down, I can go 1 group of 2, 2 groups of 2, 3 groups of 2. Okay, that's right. Is it also 3 plus 3? 1, 2, 3 plus 1, 2, 3. Hey, that's looking pretty good. Let's look at this one. Could we have 2 groups of 3? 1 group of 3, 2 groups of 3. So that's right so far. But look at this choice right here. This one got our kids when we had this one on the test in 2018 because it looks so similar to what? That's right, repeated addition. But is it repeated addition? No, it's not. Does the picture show 2 times 2 times 2? No, it shows 2 plus 2 plus 2. So this one right here, that one is a misconception or a really easy gotcha, like it's not correct, but it looks very similar to being correct. And this one has 3 plus 3 plus 3. Well, we have 3 plus 3, but there's no other 3, so that one can't be right. Okay, so we really have to analyze. But this right here, you will see often, and it's a trick. They're trying to trick the students right there. Okay, so let's look at the 2016 question. I already see right here that trick again. So let's see. Zachary lists some different methods he thinks he can use to solve the multiplication problem shown. 8 times 4, or what's another way we can say it, class? That's right, 8 groups of 4. Which of these is not a method Zachary can use to get the correct answer? Oh, that not word again drives me insane. So that means 3 of these are going to be right and 1 of them is going to be wrong. Now, I can see some of these not questions turning into multi-select questions where it's like 2 of them correct and they have to choose 2 correct answer choices. So keep that in mind too as we're moving into STAR 2.0. But as for this one, which of these is not a method Zachary can use to get 8 groups of 4? Well, let's look at this one. I have 1, 2, 3, 4, 5, 6, 7, 8 groups, and there are 4 in each. So that would help me get 8 times 4. Okay, 8 times 8 times 8 times 8. That's that tricky one. If it were 8 plus 8 plus 8 plus 8, that would be correct. But 8 times 8 times 8 times 8, that is not correct. And then let's look at the skip counting. 4, 8, 12. Okay, so we're counting by 4s. So we should need 8 times when we're skip counting, right? So, and let's check. Let's make sure they're right. Yep, 16, 20 plus 4 more, plus 4 more, plus 4 more. 1, 2, 3, 4, 5, 6, 7, 8. They counted up by 4s 8 times, so that would match. And then, oh my goodness, let's look at the number line again. What do you notice? Will this be important when we're teaching? And how can we ensure that students understand that this is still skip counting by 4s, but the number line is skip counting by 2s. But as far as our jumps, we're still jumping by 4. Notice we're landing on the same numbers that are here in the skip counting. We're landing on 4, then 8, then 12, then 16, then 20, then 24, 28, and 32. And so the answers are matching also. And if we count all of these little counters, that would be 32 counters as well. But I think this is important for our teaching. Sometimes we're going to do this on number lines that count by 1s, but sometimes we're going to show it where the number line counts by 2s. But notice what the hops are counting by, okay? All right, so how do we teach this? We teach this, we create anchor charts. This page is actually from Math in Practice, yay, 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 one of my favorite books. You notice there's that's used a lot of times in your teach method. So the first days, Wednesday and Thursday, this is what we would put on our anchor chart. Notice I really like how they have a word problem that goes with it. They tell you the type of model and then they show you the model. So there were 3 bags with 4 apples in each bag. How many apples were there? And so it shows 3 bags, 4 apples in each. And we could count up and show that that's 3 times 4 equals 12, right? We don't have to do the arrays and the area models yet. We'll add those to the anchor chart next week. And on Friday, we will add this one right here, the number line. Notice this number line is counting by 1s and it's jumping 4. And I think it's great to show that on your anchor chart. Notice it also has a lovely little word problem. Bailey ran on Monday, Tuesday, and Wednesday, so 3 days. Each day she ran 4 miles. How many miles did she run? What is another way, though, that we could show this on the anchor chart? Could we also show a number line that counted by 2s and do the same thing and do the jumps of 4, just like we saw in the last problem? I think absolutely. I would put both of those on my anchor chart if I were teaching multiplication this coming week. Okay, and so our other teak that goes with these teaks is 3.4K. And so it uses manipulatives, arrays, area models, skip counting, all of that within the context of 1- and 2-step word problems with multiplication and division. The trick is that most of the time that it's tested, it has been tested where they have to add and then multiply, okay? So in this question in 2021, Hector played a game 14 times. Each time he played, he threw 4 red balls and 3 green balls at a target. What is the total number of balls Hector threw at the target? And so if we add the red and green balls, we get 7 balls altogether that he throws each time. He played the game 14 times. So we're going to multiply 14 times 7. Now I realize at this point, we have not taught 2-digit by 1-digit multiplication, have we? Absolutely not. But can we use this type of question and just use a smaller number in how many times Hector played the game? Absolutely. Okay. We could say that Hector played the game 5 times, or he played the game 8 times. And so we're still using this type of problem solving just with smaller numbers. But keep in mind that this type of question will typically have some 2-digit numbers for when we get to that piece. We want to make sure we're doing problem solving like this with 2-digit numbers times 1-digit numbers later on. But right now we're going to keep it at 1-digit and 1-digit. Okay, so 2019, there was a very similar question. Gerardo bought 3 packages of mint gum and 2 packages of bubble gum. Each package had 8 pieces of gum. How many pieces of gum did Gerardo buy? And so this is exactly what I was talking about in the last one. We can take the packages of gum and add those together to get 5 packages. And each of those packages had 8 pieces of gum. So 5 times 8 is 40. And we've got our answer. Okay. So I think that is fabulous because right now that's where we are. We're 1 digit times 1 digit, but within the context of this great problem solving. Okay. And you'll notice that in your teaching. So how do we teach this? We're going to use counters or draw to find out how much it will cost, then write your answer. Now, so we're going to do a trip to the movies, and it's going to have some little movie clips in between on each slide, but then it's going to have some movie questions that will help the students use these things when they're using the counters, because we want to teach this conceptually and in context of a word problem. So this is one of the word problems when we go do a trip to the movies. For regular evening movies, the cost is $10 each for the 2 adults and $6 each for the 4 children. What will be the total cost of tickets for the family for an evening movie? Use counters to determine the cost. And so in this one, we do have a 2-digit number, but it's only for 2 adults, so they could just add 10 plus 10. However, they could also use place value blocks. This would be a great place to use the 10 rods and have 2 10 rods for the 2 adults, and then use the units 6, 6, 6, and 6 for each of the 4 children, and then put all the place value blocks together. And what's cool about this is going to help go back to their addition and thinking about, okay, once I get 10, I can regroup for a 10. Once I get 10 more, I can regroup for another 10. And so then my answer ends up being 44. Okay, so we'll be using this within the context of word problems. They won't always have 2-digit numbers in them, I promise, but I think the students will really love this activity. Okay, so if you have any questions over any of this at all, I know this was a lot jam-packed into a actual whole week, and you're watching this on a short week, so I apologize for how long this video was. But if you have any questions, please contact me, Sherry Height, at slheight@musquitoisd.org, or give me a call at extension 28705. If I'm at my desk, I'll answer, and I always try to answer questions within 24 hours. Have a great week.